Energy in physics is the capacity to do work. Furthermore, it is the power derived from utilization of physical or chemical resources, especially to provide light or heat or to work machines. It may exist in motion or kinetic energy, or at rest or potential energy. Environment is the main source of any forms of energy, and that the uses of energy has a greater impact to the environment. Upon conserving energy, the environment may suffer or may prosper. Fossil fuels, coal, oil, and natural gases do substantially more harm than renewable energy sources by most measures, including air and water pollution, damage to public health, wildlife and habitat loss, water use, and etc. Wind power generates electricity without toxic pollution or global warming emission. Harnessing power from the wind is one of the cleanest and most sustainable ways to generate electricity, as it produces no toxic pollution or global warming emissions. Wind is also abundant, inexhaustible, and affordable, which makes it viable and large-scale alternative to fossil fuels. Despite its vast potential, there are a variety of environmental impacts associated with wind power generation that should be recognized and mitigated. They include land use issues and challenges to wildlife and habitat. On the other hand, biomass power plants share some similarities with fossil fuel power plants. Both involve the combustion of a feedstock to generate electricity. Thus, biomass plants raise similar but not identical concerns about air emissions and water use as fossil fuel plants. However, the feedstock of biomass plants can be sustainably produced, while fossil fuels are non-renewable. Sources of biomass for producing electricity are diverse, ranging from energy crops like switchgrass to agricultural waste, manure, forest products and waste, and urban waste. Both the type of feedstock and the manner in which it is developed and harvested significantly affect land use and life cycle global warming emissions impacts of producing power from biomass. Matter is anything that occupies space and has mass. It is also the stuff that makes up the universe. All matter is made up of atoms, which are turn made up of a positively charged proton and negatively charged electron and the zero charged neutron. Atoms come together to form molecules, which are the building blocks for all types of matter. Both atoms and molecules are held together by a form of potential energy called chemical energy. Chemical energy is a form of potential energy which is stored in an object. There are four natural states of matters: the solids, liquids, gases, and plasma. In a solid, particles are packed tightly together so they don't move much. The electrons of each atom are constantly in motion, so the atoms have a small vibration, but they are fixed in their position. Because of these, particles in a solid have a very low kinetic energy. Solids have a definite shape as well as mass and volume and do not conform to shape of the container in which they are placed. Solids also have a high density, meaning that the particles are tightly packed together. Meanwhile, in a liquid, the particles are more loosely packed than in a solid and are able to flow around each other, giving a liquid an indefinite shape. Therefore, the liquid will conform to the shape of its container. Much like solids, liquids are incredibly difficult to compress. Gases have a great deal of space between them and have high kinetic energy. A gas has no definite shape or volume. If unconfined, The particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of container, the space between particles is reduced and the gas is compressed. Plasma is not a common state of matter here on Earth, but it may be the most common state of matter in the universe. Stars are essentially superheated balls of plasma. Plasma consists of highly charged particles with extremely high kinetic energy. The noble gases are often used to make glowing signs by using electricity to ionize them to plasma state. Environmental cycles are natural processes in which elements are continuously cycled in various forms between different compartments of the environment. There are four major types of environmental cycles. Nitrogen cycle is a biogeochemical process through which nitrogen is converted into many forms, consecutively passing from the atmosphere to the soil, to organism and back into the atmosphere. It involves several processes such as nitrogen fixation, nitrification, denitrification, decay, and putrefaction. The nitrogen gas exists in both organic and inorganic forms. Organic nitrogen exists in living organisms, and they get passed through the food chain by consumption of other living organisms. Inorganic forms of nitrogen are found in abundance in the atmosphere. This nitrogen is made available to plants by symbiotic bacteria which can convert the inert nitrogen into a usable form, such as nitrites and nitrates. Nitrogen undergoes various types of transformation to maintain a balance in the ecosystem. Furthermore, this process extends to various biomes, with the marine nitrogen cycle being one of the most complicated biogeochemical cycles. The carbon cycle describes the process in which carbon atoms continually travel from the atmosphere to the Earth and then back into the atmosphere. Since our planet and its atmosphere from a closed environment, the amount of carbon in the systems does not change. Where the carbon is located in the atmosphere or on Earth is constantly in flux. On Earth, most carbon is stored in rocks and sediments, while the rest is located in the ocean. Atmosphere and in living organisms, these are the reservoirs or sinks through which carbon cycle. Carbon is released back into the atmosphere when organisms die. Volcanoes erupt, fires blaze, fossil fuels are burned, and through a variety of other mechanisms. In the case of the ocean, carbon is continuously exchanged between the ocean surface waters and the atmosphere, or is stored for long periods of time in the ocean depths. Humans play a major role in carbon cycle through activities such as burning of fossil fuels or land development. As a result, the amount of carbon dioxide in the atmosphere is rapidly rising. It is also already considerably greater than any time in the last 800 years. Photosynthesis is the process by which green plants and certain organisms transform light energy into chemical energy. During photosynthesis in green plants, light energy is captured and used to convert water, carbon dioxide, and minerals into oxygen and energy-rich organic compounds. It would be impossible to overestimate the importance of photosynthesis in the maintenance of life of Earth. If photosynthesis ceased, there would soon be little food or other organic matter on Earth. Most organisms would disappear, and in time, Earth's atmosphere would become nearly devoid of gaseous oxygen. The only organisms able to exist under such conditions would be the chemosynthetic bacteria, which can utilize the chemical energy of certain inorganic compounds and thus are not dependent on the conservation of light energy. The last but not the least is the water cycle, which describes how water evaporates from the surface of the Earth, rises into the atmosphere, cools and condenses into rain or snow in clouds, and falls again to surface as precipitation. The water falling on land collects in rivers and lakes, soil and porous layers of rock, and much of it flows back into the ocean, where it will come once more evaporate. cycling of water in and out of the atmosphere is a significant aspect of the weather patterns on Earth. Precipitation is a vital component of how water moves through Earth's water cycle, connecting the oceans, land, and atmosphere. Knowing where it rains, how much it rains, and character of the falling rain, snow or hail allows scientists to better understand precipitation impact on streams, rivers, surface, runoff, and groundwater. Frequent and detailed measurements help scientists make models and determine changes in Earth's water cycle.